Question 6. A. Iron form complex ions with the monodentate ligand, the cyanide. Part 1. Complex ion A contains 1 iron 3 ion and 6 cyanide ligand. And complex ion B contains 1 iron 2 ion with 6 cyanide ligand. So from here you can get or calculate the charge, the overall charge. So iron 3 is positive 3 and the cyanide is negative 1 times 6, negative 6. Sum it up, you get negative 3. So the charge of the complex ion later is 3 negative. For the complex ion B, so you just use positive 2 because it's iron 2 ion. 6 ligand, 6 cyanide ligand, so it's 2 minus 6, so you get negative 4. That's the overall charge of the complex ion, so it's 4 negative later. Okay, so you just try to give the formula of these two complex ion. So the iron with 6 cyanide and is 3 negative, and the complex ion B is iron with 6 cyanide with 4 negative. So this is for iron 3 and iron 2. Okay, part 2. Explain why a solution containing complex ion A and solution containing complex ion B are different color. So complex ions that are different color, you just need to relate with the delta E, because A and B, they're having different delta E, the different DD splitting. So it means when the visible light is passed through the solution, so the electrons, it will absorb the wavelength and get excited. So means different delta E, it will absorb different visible light. So when different visible light being absorbed, then we see different color, different complementary color. So what you need to focus is first you need to mention, because different complex ion, the delta E is different. Delta E different, absorb different visible light wavelength. That's what you need to put. Complex ion A and B, they're having different delta E between the two sets of d orbital. These are the two sets, this one and this one, right? And therefore they will absorb different wavelength of the visible light, and we see different color. Okay, part 3. In complex ion A, the carbon atom of each cyanide ligands are bound to the iron 3 ion. State the type of bonding involved. Of course, is a dative covalent, right? Like this one. So the carbons means the cyanide ion, the lone pair on carbons will donate to the iron to form dative bond. So it will form 6 dative bonds. Okay, part B. Complex ions have different geometry. Complex ion A, this one, is octahedral, because the iron with 6 cyanide ligand, monodentate ligand, so it's octahedral. So you just draw like this. Make sure the C and the Fe bonds is there. Means the carbon is the one that form bonds, dative bond with the iron. And another ones you need to show the each geometry. And label one bond angle on each complex ion. So after you draw this structure, make sure it's 3D. 2 wedge line, 2 dotted line. It shows that these 2 cyanide is in front, these 2 cyanide is at the back, and this is just in the plane, in the principal axis. And you just need to draw the square bracket with 3 negative. So this is complex ion A. What is the bond angle? Bond angle only one is 90. So all the bond angle is 90. So between these monodentate ligands and the iron, the CFEC. And another one is silver ions form linear complex with ammonia. So something like this. Is the nitrogens that form dative bond. Make sure you put the one bond between the silver and the nitrogen. And the bond angle is the N, AgN is 180 degree, right? Linear complex. So next is a nickel form tetrahedral complex with carbon monoxide. So this one no overcharge there, because no neutral, because it's atom, nickel atoms, and the carbon monoxide is also neutral. So you just need to draw something like this, the tetrahedral. So tetrahedral is two normal line, one wedge line, one dotted line, shows that this carbonyl in front, this CO in front, and this CO at the back. So because this is tetrahedral, the bond angle between the C and IC must be 109.5 degree. Okay, the last one is the PD 2 ion form square planar with the correct. So square planar, you just need to draw something like this, two wedge line, two dotted line, and put all the corrects there. So overcharge is 2 negative. This is square planar. Okay, that's all. Thank you.